Welcome. I guess we're going to have some more people getting on soon. I will try to spread the word. Thank you all for coming. This is a learning experience for everybody. So, and that's before all the learning that Claudio is going to give us on testing.
Right.
I'm going to hand the meeting over to Claudio, let him take it from here. And everybody have a good time. If you got any questions or feedback, you can get a hold of me at michael@houstontechfest.com. Let me know how you like or dislike what's going on or any suggestions. And without further ado, here's Claudio.
Excellent. Thanks, Michael. Thanks, everybody, joining in, taking some time out of your day to join us here. As usual, support the community, get to grow the community and grow your own skills. So we hope to get to do some of that here tonight. Quick intro here. I'm Claudio Lassala. You have my email up there. If you think of any questions or comments or concerns afterwards and you need to reach out, that's how you can get a hold of me. You can also find a lot of these things that I give talks on. I also write to my blog at lassala.net. So things about the topic that we have at hand and other topics related to software development, as well as some other things that strike my passions. As you can see on the screen, besides being a software developer, I'm a technical director with Improving in the Houston office, and I've been doing software, building software since the late 90s, going from DBase, FoxPro, Visual Basic, getting into C# and .NET, Ruby on Rails. So I've been around for quite some time building software, something that I really like doing. But I'm not just your typical software developer, who only does geeky things. I also do making music, riding motorcycles. So I try to have a very entertaining life, which keeps me always going. Today's schedule, we're going to be talking about testing and smiling because, you cannot, developers cannot be standing or sitting beside me and without hearing, me talk about testing in one form or another, because through the practice of testing, I know that I've become a better developer, and I've been helping many other developers and teams to buy into the practice, as well as sell the practice into the business, and coming up with the processes to make it work for everybody, not just the developers, but the people who are feeding the developers with the user stories, the acceptance criteria that the developers are working, creating software. So we're going to be looking at the types of tests that I've been using most of the time in the last several years. The numbers involved, how many or what percentage of those tests are unit tests versus integration tests versus end-to-end tests and so on. But more importantly, what is the process? What does it look like in a typical sprint with my team, for example? What does the process look like? Because that's something that a lot of people ask. It's when do the user stories get written? When do they get reviewed by the developers? When do the acceptance criteria gets created? Who does it? Does it ever change? Does it change mid-sprint? Is it written in stone? So all these questions and how those that information makes it into tests and into the code itself. So that's very important. And why does this process and why do these practices actually bring smiles to people's face, those who are involved in the project? So that's what we're going to be covering today. All right, the types of tests that I use most of the time are unit tests, integration tests, and end-to-end tests. I don't do a lot of manual tests myself, and I do not do performance tests. It's not something that I've had a chance to work with or a need, at least on most of the projects that I've worked on. I know that they are a thing, of course, and when necessity comes, I'll look into them. As far as manual testing, of course, there is a time in the development process where we do want to have manual testing. But something that I'm going to be sharing that's very interesting about the current project that I'm working on, as an example, which I've been working on this project for a year now, and we don't have a dedicated QA person in the project. We are actually just in the process of onboarding one who will actually focus mostly on the automated tests, besides doing the manual tests as well. And how does that work, right? Having developers, a team of 5 people in the project and not having anyone who does the manual testing. How does that work? How can we get anything done, right, and deliver, software to stakeholders that is meaningful? So talk about that. And as I explain these things to to other people, to other developers, to the team, I like walking up to a whiteboard and just draw the things that are part of the project. So that's what I did one of these days. I drew it up. I took a picture of my whiteboard, and then I created this beautiful drawing. That's what you're seeing here. Because for me, it has to be that simple. I should be able to walk up to a whiteboard and draw it up to explain to somebody else. And other folks on my team should be able to do the same, right? The next day, they should be able to walk up to the board and draw it up, because it should be a simple architecture and process involved so that everybody can speak to it. When we talk about test distribution, it's very common to use a pyramid to indicate the levels of tests and the volume of tests that you have. And usually a very common pattern is to see this. At the tip of the pyramid, you have a small volume of end-to-end tests. And then you have integration tests, normally more than end-to-end tests. And then the base of the pyramid and the vast majority of tests should be unit tests. And that holds true to what I've had in excuse me, in the last several years. And I'll show you how that's distributed as an example in the project that I'm currently working on. So this project is a web application, right? It's an Angular, it could be React, it could be anything really, but it's something that gets rendered on the browser, right? Your typical, user interface that allows the user to interact with the application. Behind that user interface, there are components, there is code, there are functions, there is TypeScript, there's JavaScript. There are the things that enable the UI that the user interacts with, right? For all that code, right, the components, the functions, and the things that we have there, we write unit tests, right? It's a unit test for the Angular components, for the pure functions that we create that enable those components to do whatever work they do. We also have services on the Angular side, on the TypeScript side, and these services are essentially a way to communicate with the API, right? The API where we have the backend code that performs all of the domain logic for our business. One of the things that we do that's very important is that these services, they are swappable as we run the application, where we can switch whether we want to go to the real API, right? And then the real API could be like a test QA server, it could be production server, staging server, whatever the case might be, or it could be an in-memory version of those services that we use during the time that we don't have the actual API. Why is that important? Because we want to enable front-end development and back-end development to run in parallel and not depend on each other. That was the solution, or that is the solution that we are following. And I'll tell you where those things happen within the sprint. So taking from there, let me move it over here. In front of the application, we have the end-to-end tests. Now, some folks see end-to-end tests as in from the UI all the way to the database and back. That's not how we see end-to-end. We see end-to-end as in user's workflow, right? It's from the beginning of the user's workflow to the end. So if the user is, for example, the workflow is, user trying to purchase something on a website, well, it involves the user making a search on the website, adding products to a cart, a shopping cart, going to the cart, and then checking out. That's a process. It's a whole business workflow. So this is how we approach our end-to-end tests. And since we have this in-memory version of the services that provide data or that, quote unquote, saves data in the application, we are able to run our end-to-end tests without touching the actual APIs. Why do we want to do that? Well, for one thing, because it runs way faster than going against, microservices and all the authentication and authorization and things like that. But again, most importantly, it allows us to develop those things in parallel without dependencies. Looking at the other side of the API, right? Behind the API, we have, in this case, it's a .NET Core application. It could be really any kind. It could be like a Ruby on Rails kind of API. It could be, Node.js. However you're serving up those APIs, it really doesn't matter from the front end's perspective. All the front end sees are URLs, right, that it's calling and sending payloads or and receiving responses back. Behind those APIs, so we have controllers, your typical actions in controllers that perform the things behind the routes. Behind those things, we have commands, we have handlers, we have domain events. We're following domain-driven development, so DDD, to implement the business behavior. So things that we do here, the kinds of tests that we do here, we have integration tests against the API. Many times, like in the past, the way we used to do integration tests for this would be to instantiate the controller and then call the action that's normally called by a route. We're not doing that anymore, because when we do that, we're not really replicating the experience of an API consumer try to call into that behavior, because we are bypassing, for example, any middleware that you might have between the route and the actual controller. So if you have like authentication, authorization, and other things that you do there, you're bypassing all of that, right? So we decided to just essentially post or run a get or a post call into those endpoints, so that we get to exercise the whole thing, the whole integration between the routers and the controllers and everything that happens behind that. So we do that at this level. We do a whole bunch of unit tests against the commands, the handlers, the domain objects, the entities, the aggregates, and all that fun stuff. And some of that code, whichever part of the code actually has to touch a database, well, that's an integration test, right? So make sure that once we try to hydrate or dehydrate entities to and from the database, we want to make sure that that works as well. And since it touches the database, it's an integration test, right? So we have all of these types of tests spread through the code base like that, between front end and back end. Looking at the numbers, right? So again, looking at the whole picture here, you have the UI, right? The UI has to somehow communicate with an API. Behind that API, there's more logic there. And there are unit tests, integration tests, end-to-end tests all around the scenario here. When we look at the distribution of tests, what's the percentage of each type of test? This is what we have with numbers as of last night, right? So I looked at our code base, I've run our tests. This is what I found out, right? We have almost 2,800, just a little over 2,700 tests altogether. This is the distribution. If we look at the pyramid shape, that's what it looks like. It holds true to that distribution that a lot of people, have figured out. At the very top of the pyramid, so 4% of those almost 3,000 tests, they are end-to-end tests. They test users' workflow. They are not testing edge cases from the user's workflow, because usually the edge cases come in the shape of like some business requirements, some business validations and things like that. Those are unit tests, right? So we have a boatload of unit tests, like 87% of those almost 3,000 tests are unit tests. They're small, they're easy to write, they are quick to run. We can run thousands of them, in a very short span of time. And for integration tests, they can be a tad slower and many times much slower than unit tests, but they are still useful, right? Because if things work as unit, but they don't work well together, we don't have a solution. So we need to make sure that when we put those things together, they also work. But none of that is like the ultimate solution if the user's workflow does not work. Because you may have like beautiful code in the back end doing all of the magic queries and validation, and then you have, stuff on the UI like beautiful, Angular or React components. But then if the user workflow is not working, you don't have a solution, right? The business does not make money, and in many cases, we end up losing money because those workflows have not been properly tested. So this is what we have, and the interesting thing is that I gave this talk internally 3 months ago, and when I pulled up the numbers, I noticed yesterday that our tests within 3 months increased by 55%, but the distribution remained pretty much the same. 87, 85% here, 8% integration test, 4% end-to-end test. That was pretty impressive or interesting when I saw those numbers yesterday. Moving on here, whoops, I clicked on the wrong thing there. Just a second, there we go. We talked about numbers. Oh, usually when I share those numbers with folks, there's always somebody who asks, what about code coverage? Well, code coverage right now is about 98.7654331%. Honestly, I have no idea what the code coverage is. I have actually a link to a blog post that I put out last year titled Code Coverage is Worthless. And the point is, and it's not clickbait, or it's a little bit of clickbait, right? You have to click on it to understand what I meant with that. For the reasons that most people use code coverage, it is worthless, because I've seen people using code coverage or writing tests to satisfy code coverage to hit a certain number that somebody has defined, like, oh, 95%. If we don't have 95% code coverage, we should write more tests. And they make that a policy. And then guess what? I've seen tests that have no assertions, but that will increase code coverage. Tests without assertions, the only thing that they prove is that when they run, smoke does not come out of your app, right? Things don't blow up, but it does not verify anything. It does not verify behavior that you've intended, hopefully, with the code that you wrote. So we don't really, I have no idea, honestly, what our code coverage is, but I can tell you that our feature coverage is 100%. And how I can tell you that? It's part of the process that I'm going to be sharing in just a couple of moments. Moving on from there, and again, on that blog post, I do describe when I use code coverage. What is the case that, to me, it makes sense to use code coverage, but it's not like a mandatory thing. So the process, that may be the most important part of this whole talk tonight, because I have other talks. If you look up online, I have other talks about like refactoring test code, TDD, and what else have I done? Context-based testing and things like that, where I get closer to, okay, this is how we write tests. This is how I refactor tests, and this is how I organize tests. That's not the point for this talk. I'm going to have a little bit of that towards the end, but the core of it is the process. Now, this process starts at the moment where, after our business analyst has worked with our product owner to identify the main direction of the product that we're building, and the main stories, like the main story groups that we're working, maybe the epics and the main stories within those epics. And they have a starting point as far as what the acceptance criteria for those stories would be. So once they have that, they put, then our process starts as far as the team goes. So these are some of the steps. I don't actually have all of them here, but the areas that we're going to cover: backlog refinement, sprint planning, design sessions, development on the front end and on the back end, the integration between the two, where the end-to-end tests fit in. And I didn't include here sprint review and sprint retro, but those are also very, very important parts of our process, and I'll touch on those as well. Backlog refinement. That's a meeting that we have every other week. So we run 2-week sprints. In the Thursday of the first week in the sprint, we get together for an hour and a half, the whole team, all the developers, the business analyst, and the product owner, and they bring the user stories so that we can discuss as a team to make sure that the team understands what's in there, what's in those stories, why they exist, why they are important. And then we can have a ballpark, or even in many cases, we are going to size those stories given our current understanding of the stories. So we look at the stories, we look at the high level acceptance criteria for those stories, and we look at mock-ups. So depending on the story, if we do need something visual to kind of have everybody on the same picture, well, we use mock-ups to facilitate the conversation. As far as the stories go, we make a point to write the stories following this template here. In order to, what is the business value that we're trying to achieve? SA, what's the type of user, the role of the user, and a little bit about the context of that user. I'll talk a little bit about that in a moment. I want to, what is it that I want to do? As opposed to SA, I want to, so that, right? So I have, again, and I'll share with Michael later a link to this presentation so that you guys can get to all of these links that I have listed on my slides. But it's just a little more information for you to see where I'm coming from as far, like in this case, how do we like seeing those user stories? Starting the user stories within order to is extremely important because it immediately sets the tone with the team as to why are we getting paid to work on this feature? Why does this feature matter? If the in order to sentence does not give us that, at this point in time, everybody in the team or somebody in the team will go, but why is that important? And it sparks that conversation, right? And the business analyst, the product owner, they're used to that now, so they know if that the team might be asking those questions if we don't have a clear answer or if we don't understand what the sentence says there. The SA part, we also make sure to understand, we don't want to see just like as a salesperson. We want to know a little bit more, like what is the context under which for this story, it will make sense for that user to use it. So for example, as a salesperson taking a phone call with a customer, that's one thing. Or as a salesperson working on my desktop computer. So I know that, the person will have at least one monitor, or nowadays probably 2 or 3 monitors. Or as a salesperson working with a customer on my phone. It's like the only thing I have to help this customer is my phone. That is extremely important because if you don't know how much real estate that user is going to have, how are you going to design a proper solution to enable that user to get whatever they need to do done, right? So we've been putting that kind of information on the user story as well so that we understand those things, and then we can come up with better solutions when we are designing the how we're putting together the feature, and later how we're going to be implementing the feature. The acceptance criteria, it's very high level, right? It's kind of like the typical template, demonstrate that the feature does this other thing, and this other thing here. Like some really quick bullet points just to shape what we're going to be looking for in that, but we don't spend like a whole lot of time describing the acceptance criteria. Not in that meeting, right? Not in backlog refinement. That's a little more overview there without that level of details. And again, when appropriate, we want to look at screen mockups. We've been using Balsamiq as a tool to create, mockups kind of like this. This is one on the Balsamiq website, but this is what these mockups look like. Really, we just use that because it's an easy tool to use. It's very quick to create mockups like that. But at the end of the day, we may just walk up to a whiteboard and draw something up. We may pick up a napkin and draw at the back of a napkin and say, oh, is this what you mean? Right? It's really there not to dictate what kind of UI controls you're going to be using. It's just there to facilitate communication. Many times, and quite often actually, we see a mockup that maybe shows like a drop-down type of thing, but when we're having the conversation, we ask, is that supposed to be a drop-down or just a list that the user can pick from? And it's usually the latter. It's like, it's whatever makes the most sense for this screen, for the kind of real estates that we're going to have, for the user to make a selection. Whether it's a drop-down, a regular list, whether it varies. Sometimes it's like, well, if you only have 2 options on that list, maybe you don't want to show a drop-down. Like, you don't want to show a drop-down for a yes, no thing. It's 2 clicks for the user to do one selection. If that list grows and now you have something where it's like, well, now we're seeing too much, well, yeah, then a drop-down would make more sense. So we have these conversations. Every time we have refinement, we go over these conversations. Once those are cleared and we understand where we are going with things, then, next Monday or 2 Mondays from that meeting, we have our sprint planning. The first part is okay, what are we going to be working on? What are the features or what are the user stories that we are going to be putting in these sprints based on the sizing and our velocity? What can we make fit, right? We take a quick look at the stories and have a discussion if needed. So most of the time we've already discussed them enough in the refinement session. But what happens oftentimes is we have a refinement session and then 2 sprints later, we actually start working on a given story that we discussed, a month prior to it. So we may either not fully remember all the discussion, or we might have learned things we didn't know when we first look at those stories. We may have learned something about the business, something about the technology that we are using, something about the patterns that surfaced or that formed over the last 2 sprints as we were working on other stories that maybe were similar, right? So we may end up having, some extra discussion on the story to update our current understanding of that one story. So maybe the story now is going to be bigger, maybe it's going to be smaller, maybe it's going to be the same size, but we have a different approach to how we are going to be implementing that based on our previous experience from the last 2 sprints. So we have those conversations. We always have those conversations. We never take the story as it is as something that's written in stone. It's always a placeholder for conversation. That's what user stories are meant to be, right? Made the story selection based on sizing and all that. Find a good balance of story sizes. Don't get like 3 huge stories. We take one big one and then a medium and a small one, or a couple of small ones. We try to balance things. Also thinking about, are there dependencies between those stories? Is there a situation where we may run into merging conflicts, right? Because if there's maybe dependencies on the features and we need to finish one and then start a new one, do we cut a new branch off of the previous one? Do we merge it? What do we do? So we talk to those things to avoid merging conflicts and things that could delay the development process within the sprint. At that point, we also enhance the acceptance criteria in our stories with scenarios and given when then statements. I have, again, a blog post about having given when thens, where years ago in 2017, I started like this movement. If I don't have given when then acceptance criteria, there's no code. I am not writing code if I don't get stories that have given when then statements. Why is that? Because it's easier, you know, from past experience, it's easier and cheaper to write English sentences to describe what we are going to be building, as opposed to not knowing what we are building and then writing programming language code, Java, C#, TypeScript, what have you, to then figure out that, yeah, that code that we wrote, it does not actually yield what the business needs. Well, so let's explain that in English first before we write the actual code. So this is something that's I've worked in projects where by the time we have planning, somebody has already written those given when then scenarios or statements. In our current project, what we do is, as a team, we write those. As we are in planning, we are looking at the story, we have the initial high level acceptance criteria. We start identifying, okay, what are the scenarios for that story? For example, if the story is, it's a feature for the user to go to an ATM and withdraw some money. Scenarios could be, the user does not have any debit card, but they do have their fingerprint and they have like some PIN code. Are they able to withdraw money like that? Right? They do have a credit card, but not a debit card. Right? They have a debit card, but don't remember their PIN number. So these are the scenarios that we identify and say, okay, for these scenarios, which ones are we actually tackling for this story? And then we describe, right? Given the user is an account holder and the user has a debit card and the user has a PIN number, right? And then that's the given. When they try to withdraw money and they enter like $50, then, you know, the hello, hello. Guess you guys lost me for a moment, right? All right, good. So we, as a team, we describe those scenarios, right? We make sure that, okay, everybody on the team understands what the scenarios are, what the context of each scenario is. And once we have that, all right, we move on to the next thing. We move on to the how part of sprint planning, which some people call tasking, right? Which is really what we're doing. It's like, okay, now that we know what we're going to be building, now we're going to discuss how you're going to accomplish, right? So what we do is we create our tasks. We do that as a team. So instead of having like one person pick up one story and then writes out the tasks, we do that together as a team. Okay, for this story, what are the tasks that we know we're going to have to accomplish? And then we think all the way through. We think from the front end. So we think, well, we're going to need to update the menu. We're going to need to create a component to show a list. And then we're going to need to create a component to show a confirmation message, right? What have you. And then we're going to need to create a service that calls into the API. And then we're going to have to do this, that. We spell those out because even those who may not be the people who will be actually writing the code, they contribute to just making us think through the work that has to be done. And then we think about from the backend perspective. Well, we're going to need to create one endpoint to retrieve a list, and we are going to have to create one endpoint to create the data, and we need to write some code to validate the business rules. How many business rules? Are they complex? There are a bunch of them, or just a simple one? So we think through those, we create tasks for those, we flush out those tasks, and then we move on. The tasks will always include a task for design session, which is something I'm going to talk next. So for each story, we need to have a design session, period. We're going to have a test for the end-to-end tests. So here's where I told you that even though we don't look at code coverage, we look at feature coverage. And this is how I know that we have 100% feature coverage, because for every single story, we have a task to account for the end-to-end tests. It could be a part of a definition of done, if you will. We just decided to have a task on the board so that it's not something we're ever going to forget, because it's sitting right there together with the story. Talked about the API endpoints that need to be created or changed, and then the tests for the front end stuff, the test for the back end stuff, and whichever other tasks we might need to accomplish that one story. Design sessions. What are those? So usually, either if we have time and if the team is not like burned out from meetings, which hasn't been the case, we've been very quick through these meetings because of the way we've been having all these conversations prior to it. So we end up like at the end of the second half of the first day into the sprint, we run design sessions. So we take a user story, we look at its acceptance criteria, and we talk about things like, okay, authorization. What are the permissions necessary for a user to have in order to be able to execute or to access this feature on the system? Are there policies? Policies are like an aggregate of permissions that apply to a bigger story, a bigger feature that the user may be trying to accomplish through the system. And then we look at the endpoints we said we're going to have to create. And then again, as a team, we discuss what are those endpoints going to look like? Is it going to be, API / V1 / accounting / what? Accounts or transactions, or we discuss that, right? We define that. Is that going to be a get? Is it going to be a post? What is the payload? What are we sending in? What is the response? What are we getting back out? So we spec those out, like we document that and we put that together with the story. Why do we do that? Because that way, remember I mentioned in the front end, we have an in-memory representation of the APIs that we're going to be consuming. Well, since for the front end development, we have that contract, we can build our UI without having a backend. Right? Because as long as we have something that will serve up that data, that JSON, then we're good, right? So we define that so that the front end can start work. And same thing from the backend's perspective. So from the backend's perspective, it's like, well, we're going to have to serve up this route for this endpoint, which is implemented with this controller here. And we are following the CQRS pattern, command query segregation responsibility, where we have either commands or queries coming into those controllers, and then they are dispatched through mediators that will then handle those commands. So we discuss what is coming in, what's going out. Once we've specified that, or we've, and here's what happens. Sometimes there are stories that are very complex, and we may spend like a whole hour just doing design for that one story. Depending on what time of the day we are done with that one story, if there are other stories, then the team just decides, hey, look, we already have one story spec'd out. We can start working on it, as quickly as possible. Let's work on it like 2 or 3 days, and then do the next design session for the other stories, right? So we try to just like, we don't do it all at once to not get to a point where it's like, whatever, right? We are so burned out that we're not really thinking through the design. And then at that point, it defeats the purpose. So the team is pretty good at identifying those and understanding, do we have enough work to get us through the next couple of days or so? When is it that we need a new design session? Get it on the calendar, everybody gets together, and we keep moving like that. So at that point, we haven't had like burn down charts. We don't use burn down charts. We do not size our tasks in terms of hours, right? It's just like, well, we have all these tasks here, and they are just things that have to happen, that have to be done in order for the story to be called done. And that's how we've been working, and it's been working pretty well, right? On the beginning, it was, we were like learning how to identify these things and, to gauge the amount of work involved. And then we just keep getting better and better, the more we do it. All right. I failed to mention, if anybody has questions, please use the Q&A feature. I guess, Michael, do we have a Q&A feature, or a chat window or something where folks can send questions?
Yeah, I got to unmute the chat.
I wonder if this, I don't know. Is there like different things in Teams that you can do as far as like whether you use the chat window or the Q&A feature?
Yeah, I unmuted it. Let's see if we get any chat messages. I'll let you know.
Okay, sounds good. All right, so we got our design sessions done. The team has specified what are the contracts to those endpoints, what are the inputs, what is the output, and that's extremely important, right? Because the front end knows that as the user interacts with the front end, it's going to produce API calls, right? So as long as that front end code produces those API calls, you're good. And then the back end understands that there are going to be, API calls coming in with a certain payload. And then depending on business logic, given a certain payload, there's a certain response that is expected from the front end. As long as that response comes out in the shape that we've defined as part of the design, as part of that contract, you're good, right? So at that point, the front end development can start right away. I've worked in so many projects in the past where the work would get delayed because the back-end work was a little bit harder than the front-end work, and then the front-end work would not start until the back-end was done. Like, why do we have such a dependency on the thing, right? If we specify those interfaces, right, those contracts, just program to the contract, not to the actual implementation, right? With this flow, on day one, or I guess by then on day 2 of the sprints, both front-end and back-end development can start at the same time without waiting on one another. So good stuff there. Front-end starts working. One of the first things that we do in the front-end side of things is to create those in-memory services, right? So those are simply, objects that will represent those APIs that we are going to be producing in the backend at some point. Like in this case, APIs for sellers, for vendors, for our tagging system, for authorization, for lots, for customers, buyers, and so on, right? So these guys, the only thing that they do is to produce some fake data that when the front end calls, it's going to say, hey, here, use this data, right? This should be enough for you to show your pretty colors and show your UI controls and do your UX, because UX is extremely important here for us, right? So everything the front end needs, it's right there, right? No need to touch a database, no need to touch APIs, no need to touch any of that. Get the work going. Next, we start working on the visual elements of the feature. Like for instance, there was a feature here that uses a tree of categories, right? Like a tree view of sorts representing categories. So in that folder, we have our HTML, we have our CSS styles, we have our actual component code. And then it's a common practice to have also a file with the tests for that component. We follow something we call context-based testing. So instead of having one file with all of the tests for the thing that we are testing, in this case, a component, we have a folder, right? In this case, category tree specs, that has a different files for the different scenarios that we have tests for that component, right? So it looks somewhat like this. For the category tree specs, we have, within that component, we have a feature to add a nested level category, display categories, display an edit control for in-place edit for a category, display a node within a node, and so on. So each one of those little things are like smaller bits that are served by that main component. So we have one folder for each one of those, and then one file per context for each one of those little features. So for instance, display edit control, scenario being the user does not have the permission. What happens then? The user does have permission. What happens then? Displaying node. We may show existing category that has an error associated with it. Maybe it's a duplicate category that is not allowed, or the name has invalid characters. Showing existing category without error. Showing a new category, right? So again, instead of having one file with all of those features, we have it all separated as folders and files. Makes it easier to navigate the solution that way. And then looking at each one of those files, remember we talked about given, when, then. This is how those tests look like. And these are like the Angular tests. I've worked on React apps where the tests look pretty much the same, right? Sometimes the syntax works slightly different. Like in this case, this is TypeScript, and we are leveraging, object-oriented programming from classes that we get and inheritance and stuff like that in TypeScript. So we are leveraging that. So this is the syntax that we are using. In other, frameworks or tech stacks, the syntax may look different, but the English part is preserved, right? Where we have, hey, for the category tree components, when we are editing category and we are entering the edit form for an existing category, there is a given, when, then description for that, right? So at this point, it's very easy for us to come in here and read, right, the acceptance criteria. In this case, for a visual component, right? If we look at the user story, the user story is not going to describe this because here we are describing a visual element of the solution, an Angular component. But even though we are building something technical here, notice that we preserve the language, right? We still like spell out what is it that we are doing here? Why is it important? It's very well described there. So we have that. Moving on from there, backend development, like I said, starts also right away without having to wait on the front end, making calls into APIs. Like, no, the front end is doing their thing, backend, is doing their thing. We also work through writing integration tests, meaning, hey, we're going to post to a given endpoint a certain payload, and we expect the following results. And then behind that, we have controllers, commands, handlers, entities, aggregates. So we have unit tests for those. And funny thing, we don't have a database yet, right? Even though we have our entities, we are setting up entity framework and all that kind of fun stuff. We're just using an in-memory database right now because we're focusing on the user workflows. We're trying to get that, nailed. And once we get that, like very stable, it's like, okay, now we know what the UX is supposed to be like. We know how the UI is going to communicate with the backends, right? We already have things in place that will serve up the queries and the behavior that we need. All right, now let's figure out how we're going to persist that against the, whether it's going to be a relational database, SQL Server, Oracle, whether it's going to be a document database, MongoDB, or, you name it. That's an implementation detail that has nothing to do with the user workflows, the business features that we're building, right? So we're making this pretty rapid developments, focusing on the things that matter at the moment. It's not that, a database is not important. It's not important right now, at this moment. So with that in mind, we structure our Visual Studio solution, our .NET solution, much like we just saw in the Angular side, right? Where we have, in this case, an integration test folder. But most importantly, we have the areas of the business, like accounting, catalog, sales, purchasing, and so on. And then, for example, under catalog, we have categories. We have countries of origin, items, sundry items, tags, and so on. Within each one of those, we have the different features, like how we check for code uniqueness for categories. How do we create categories? How do we retrieve them? How do we retrieve tags associated with a category? How do we update categories? And then within each one of those, we have the different scenarios. We may have a happy path. We may be trying to create a category with a name that's already being used. So, name uniqueness is also something important here for this one feature. Right, so we describe it or we organize it in that manner. Look at the test. Even though this is C#, as I mentioned, the syntax looks slightly different, right? Because here we are in C# using XUnit as a test framework. But notice that we also use the same English language, right? The same given, when, then. The same way when we are looking at the Angular test, we see given, when, then. When we're looking at C# code, backend code, we are looking at given, when, then. It just flows. As human beings, we're using natural language here, the language that we use to have conversations. That's our point of entry into the code, right? And then like here we see, okay, this is an integration test for this endpoint. What is the endpoint? Oh, it looks like this, right? And if I keep like scrolling down the actual test, then we see, what does the payload look like? What do we expect the response to look like? This test describes those things. If I move over to the unit test folder right underneath, the organization very similar, right? The same approach, right? What are the areas? What are the main features like allergens, credit terms, customers, package types? And then within those, what are the features? Archiving, creating, retrieving. And then within those, like validating. Discount percentage scale is validated on creation. Name uniqueness, required data, validation context, which drives the main context behind validation. You look at the test, guess what? No surprise. Given, when, then here for this scenario where all required data is provided, all required data missing. That's the scenario that we're modeling here, right? So as we look into tests as a way to learn the solution that we have implemented, this is what we read. We read English. Once we want to see the actual implementation, the C#, the TypeScript, F12, right? Go to definition, and then you see the actual code, right? This kind of stuff, by the way, again, it doesn't matter where. If we are on the front end, on the back end, integration test, unit test, we can get our business analyst, we can get our product owner, the non-technical folks to look at this and help us validate, help us developers, the folks writing the code, they can help us validate, like, are these assumptions correct, right? And if they're not, what are we missing, right? Because even if we look at given the command contains all required data, what is the required data? When we look into the implementation of that method, we're going to see, name is required, code is required, this other thing is required. And then the non-technical person may look at that and say, oh, you're missing one field there that's required and it's not showing in that list. Okay, let's work on it, right? We can have that conversation, that understanding of the feature, and then move on from there. All right, integration. You have the integration test, the unit test, the front end and the back end. You want to make sure that when the front end and the back end, they're both done, you have to put them together, right? Because we've been working with stubbing out calls and, using mocks and things like that. Now we need to put them together and make sure that they work, right? Once we've done that, right? Yep, we've plugged them together. They are working fine. We demo it to the product owner. Once we've demoed to the product owner to make sure, hey, is this what we discussed in planning? Are you happy with the feature? We get a thumbs up. All right. We prepare to do sprint review, where we are going to present what we've created to the other stakeholders, right, of the product, and they're going to get their feedback. We're going to gauge their reactions to certain things that we've put together. It's the first time that they are seeing it. And some things are going to be thumbs down, some things are going to be other things are going to be no, that's not what we need. I can tell you, because of the way we are approaching this, I don't remember us having like thumbs down. We've had things where it's like, oh, since we can do that, can we also do this other thing, right? So it's usually like either validating or building on top of what we've created, which is very reassuring for us. So we gather the feedback from the stakeholders. We see like what kind of main changes we may need to do to the implementation that we just showed to them. Oh, actually, sorry, I didn't update those. When we go for sprint retro as a team, the whole team like took notes based on the feedback, because different people will like write down different notes from feedback that they heard. So we put it all together as a team, and then we decide, okay, these are the things that we're going to take on the next sprint. These are some things that we should consider moving forward, because it's something that really resonated with the stakeholders. Maybe it was the first time we've presented a solution, a specific solution to them. They said they loved it. All right, so how can we replicate that or make it easier to replicate in future stories? So we have those discussions as well. As we stabilize the new feature, that's when we actually take the time to write the end-to-end tests, right? Because now that we've put it in front of the users or the stakeholders, they said, this is how we want to move forward with this. Then we do the end-to-end test, the user activity, right? So the user is trying to do this one thing, and we want to make sure that through the front end, through the UI, they're able to do that. As we're doing that, we stub off the API calls. Why? End-to-end tests are slow by nature. They are automating the web browser, which is always a slow operation. If besides being slowed down because of the browser communication, we also need to call out to APIs that may be on a different server, on a different box, on a different process, that all slows the test down even more. And then people will not run the tests because they're taking way too long. So what we do, we cut all of those calls to the APIs by mocking those APIs. And what we validate is the following. Given the following API, given the following interaction between the user and the application, does the application create the API calls that we've designed it to create? If it does, we are good, right? And given that a certain API produces the following data, does the front end know what to do with it? Does it show the proper things to the user? Does it let the user interact with that information? If so, we are good with that. We've tested the end-to-end workflow. Well, but what about testing that against production, like, live thing? Yeah, we are looking into tagging certain tests to be able to run it against the real thing, the production thing. But those tests would not create data, they would not change data, they would not destroy data, because that's the production server, right? We don't want to do that. So that's what we are gearing towards, having these tests where we can flip a switch and either run them only against stubbed data to make sure that the operations happen on the front end side of things, and being able to tag certain tests to be able to run it against a staging server, a production server, as like a smoke test type of thing, or to see, if there are situations where maybe we're calling out to a third-party API that we don't control, and we want to see if the application is behaving, based on maybe that API call is taking like 2 minutes. What do we do? How does the UI react to that? Those tests are more expensive. They are slower. So we're only going to invest time, resources, and money into those if they really yield value back to the business, either in the shape of, making money to the business or making the business lose money. So then we need to invest some time into writing tests for, from that angle. This is what the end-to-end tests look like, and we are approaching the end of the talk, by the way. This is what the end-to-end tests look like. They sit in the front-end side of things. They are we are using Cypress.io as the stack for that. They sit in the front-end side of things under the Cypress folder. They call it integration for whatever reason. We internally just call them end-to-end tests. But they are also organized the same way we've seen all the other types of tests this far. Accounting, catalog, operations, purchasing, selling, and so on. For each one of those, what is the feature? Like, under purchasing, we are able to, or the user is able to draft a new order, a new purchase order. Okay, what are the scenarios? In this case, when they place an order, the certain customers may have what they call an order guide, meaning, hey, every time this customer places an order, 8 out of 10 times, these are the items that they purchase. Okay, so let's just create a new order and pre-populate with those things. Others don't have a default order guide, so it should be just an empty order. So we consider those scenarios and look at the test itself. Again, given when then, right? Now it's a Cypress test, it's an end-to-end test, but the description of the test is the same. Things that we learn from reading this test is the following. Okay, so when we are purchasing, in the case of drafting a new purchase order, and there is a default order guide available, given I have a permission to purchasing vendor list view, purchasing order list view, purchasing order start, meaning I can start a new order. So these are the permissions needed for the user to accomplish this distinct workflow. So as we are learning the system, or if somebody joins in the project, or if somebody tries to understand, hey, when somebody's trying to start a purchase order, how does that work? Well, we can read the test like that, because it tells us the permissions. It tells us, hey, this is the workflow that we've coded for, right? If that does not map or match the business needs anymore, okay, we come in and we change that workflow. But when we built this feature, that was the current understanding of the feature as we had it, right? As the user story, as the acceptance criteria, as we had it. If that has changed ever since, that's fine. We update this and we change the feature, right? So that's all great, good stuff. Finally, last but not least, why do we smile when we have such a process and very like dialed in process with the whole team, with the business, technical and non-technical people? The trips back to the drawing board are rare. How many times, how many projects have you worked on where you get the requirements from the business, you spend a couple of sprints working on it, you put it in front of the business, in front of the stakeholders, they look at it, it's like, nope, that's not at all what we need. And you have to go back to the drawing board, right? And now you've already created a database, you've created maybe start procedures, you've created your data access layer, you've created your entities, you've created a bunch of UI stuff. Now you're gonna have to change all of that, right? That sucks. It wastes a lot of time and effort and patience. By following such a process, like I said, I don't remember there was one situation where we had to go back to a drawing board on a feature because we had evolved our understanding of the feature, and we found, as we've learned better about the business, we figured that there was a better way to implement that feature moving forward. It was one case in a year. All the other cases is we have our conversations with our product owner, we put it in front of the stakeholders say, yeah, that's what we need. All right, call it done, move on to the next thing, right? The solution is documented as per our conversations. Because we have these constant conversations in backlog refinement, in sprint planning, in sprint review, in retro, we write our tests to put into words what we've learned from those conversations. The solution is documented. A year later, we look back at it it's like, well, what the heck were we thinking when we did that? Well, the test will tell us, right? It's not what were we thinking. It's like, what was our understanding at the time we wrote this feature? It's there. It's documented by tests, right? Things become easier to change. Like if we need to change existing features or add features in an area that already exists, well, we can look at the area, we can look at the folder structure through all those tests and say, oh, it's a new feature here. Okay, we already have tests around that area. So we have a ballpark as to, okay, how does that feature work? Can we use an API that already exists? Do we need to change an API that exists, or create a new version of the API, or create a new endpoint altogether? Makes it easier. It makes it easier to keep the testing practice, because since it's not as hard to maintain those tests, developers are fine with actually going in and making the change to the test before they write code, because that's the practice, right? If you find a bug, you write a test first, and then you change the code. If there is a change in a requirement change, you write a test for the new requirements, and then you implement the code. I see people dropping the practice when the tests are too cluttered, and then nobody wants to maintain those anymore. Well, with this approach, no, it's not that hard to actually find where things are. And another byproduct is it improves the code quality, right? Because since the tests are well written, are clean, are easy to understand, now we can actually, have the tests as something that will enable us to do refactoring, right? Which is changing the internal implementation without changing the external behavior, because the external behavior is documented with the tests. And then we can go in and make our code better as needed. And that was the end of it. Did we get any questions, Michael?
No questions.
Okay, not a problem. I have up on the presentation again my email. If anybody comes up with questions or comments or suggestions or what have you afterwards, please reach out to me. Also check out with Improving, we have a series of free lunch and learn events, or what we call now Improving Talks. You go to improving.com/virtual-events. Every Friday at noon Central Time, we have some interesting topic that you can just join in for free and check out. And I also run a virtualbrownbag.com or Virtual Brown Bag weekly meeting. You can find information on the website every Thursday, also at noon. It's an open discussion. We get together every week and we just talk about whatever it is that we've been working on. Like, oh, this week I've been working on Cypress IO. Oh, this week, I've updated, my my .NET Core to version X. Or this week I've started reading this book that's very exciting because of whatever. So it's just a way to have conversations and keep things going and people learning and, raising awareness to things that, other folks may not be familiar with. Like maybe some folks are not familiar with TDD, with BDD, with Azure, with whatever. We just talk and we learn together that way. Other than that, thank you very much for attending.
Thank you very much, Claudio. That was very good. We will be posting the recording to the Facebook as soon as we get it up. Thank you very much, everybody, for coming. Good night.
Excellent.